our previous video, we looked at a way to form reflections simply by eyeballing our points and making sure that they were symmetrical about our mirror line. It turns out that if our mirror line is one of four special lines, either the x-axis, the y-axis, or the line y equals x or negative x, we also have some rules, some shortcuts we can use to find our points as well. So looking back in your notes, or maybe you have these memorized, let's go ahead and fill out this chart, starting with doing a reflection over the x-axis. So looking at my notes, I can see that the rule we came up with in class was we had used a and b instead of x and y, so don't let that confuse you. We said let's keep the first coordinate the same, but then do the opposite of the second coordinate, and that would have the effect of reflecting the point over the x-axis, the horizontal axis. Now, you may have heard me say this a second ago. Say this as the opposite of b. Don't say negative b, say the opposite, because if that value starts out negative, it becomes opposite or positive. So let's use that rule to find our three new coordinates for reflecting over the x-axis, and then we'll go ahead and graph it and see if it looks right. That's one thing that's great about these reflection problems. You can always graph them to see if your picture looks correct, because you know what a reflection should look like. So let's again start with the x-axis. I'm going to call it a prime for my reflection, b prime, and then c prime. So my rule said to keep the first coordinate the same, so 1 will remain a 1, but then we'll change the sign of the second coordinate, so 1, negative 3. Next up, the first coordinate stays the same. Now I can't have negative 0, so 0 would just remain where it is. Now notice that b and b prime are at the same location. When we take a look at what that looks like on a graph, we'll see why that point didn't change. And then finally, c prime should be at the coordinate 4, that will remain the same, and then negative 2 when I change its sign. Okay, so there's our three coordinates. Let's graph that and see if that does look like a reflection over the x-axis. So here's a graph that we can use. I'm going to go ahead and draw in my mirror line. It was the x-axis, which is this horizontal line right along here. So there's my mirror line. Let's graph the three coordinates we came up with and see that it does in fact form a reflection. So you may have to flip back in your notes or look at your notes to see those coordinates, but a prime was located at 1, negative 3. So a prime is going to be right there. B prime was at 2, 0, and I can see why that's going to be the case. Since B was right on the mirror, it would stay where it is. And then C prime was located at 4 and negative 2. And if I connect those and of course label them as we always want to do, I can see that yeah, that did make a reflection over the x-axis. A prime, B prime, and C prime. Okay, let's go ahead and try the y-axis one as well. So going back to our previous screen, checking my notes, I can see that the rule for the y-axis reflection is to do the opposite of A this time and keep the B coordinate by itself. So what I think would be a great thing to do is have you guys pause the video right now, try to find the new coordinates. Actually, let me say one thing about that. This time I'm going to call this a double prime to show that this is a second image, so 2 apostrophes, and then B double prime and C double prime. So at this point, why don't you go ahead and pause the video. Also, go ahead and graph those coordinates you find as well and see if it does look correct. Once you've done it, you can let the video play through and check your work against mine, and then we'll finish up with that final reflection. So there are the coordinates that I came up with. I've changed the first one, I've made it the opposite. The second coordinate has remained the same. Let's go ahead and take a look at what your graph looks like as well. So this time we use the y-axis, the vertical axis as the mirror. The purple triangle is my image of A double prime, B double prime, and C double prime. And yeah, I can see that my coordinates matched up. I can see the symmetry in that. So let's go back and do one more reflection this time. And this is where our rules are really helpful, because for our last line, we're going to use the line y equals negative x as the mirror line. If you recall from class, that line is that perfect diagonal line going through the origin that looks something like that. So using the eyeball method, it's much harder to do when your mirror is at an angle like this. So the rule is going to be really helpful. Looking at my notes, I can see that the rule for doing a reflection over the line y equals negative x is to do the rule opposite of B. Oops, sorry. sorry, one second, opposite of B, and then opposite of A. So this time, not only am I changing coordinates, but I'm also changing the order of the coordinates. The Y value goes in front and the X value goes in back. So this time, it probably doesn't surprise you to know that last time we called it double prime, so this time we'll call it triple prime to indicate that it's the third image that we're forming. Once again, our rule says to not only switch the signs of our terms, our coordinates, but also change their order. So A triple prime is going to be now located at -3, -1. I've changed the order of X and Y and changed their signs. B triple prime is going to be located at 0. I can't have a -0. -2 once I switch the order around. And finally, C triple prime is located at the point -2, -4. Okay, let's go ahead and actually graph this so we can see what this reflection looks like. I'm going to go ahead and erase the ones we've done because this will get a little bit messy. If you want to keep it on the same graph though, that's fine, but let me go ahead and switch over and I'm going to get this one started. So there's my green mirror line, the line y equals -x, acting as my mirror. Oops, let's pause that real quick, sorry. Let me go back real quick. So there's my reflection over the line y equals -x. It's a lot harder to do the eyeball method for this, but I can imagine, to check my answer, if I were to fold my paper where that diagonal line is drawn, that I can see that, yeah, those coordinates would match up to where they initially started. So there's how to form reflections using, I call them the AB rules.